Hi, welcome to our pre-calculus. Today's lecture is composition of trigonometric functions with variable expressions as input. So we are going to have one trig function, one inverse trig function, and the first input is a variable. Here's an example. What is tangent of sine inverse of u? What is u? Well, u is just some number. It's an algebraic expression. All the problems we have done so far, there was a specific number, and now we are upgrading to a general case. You remember the last lecture, we gave a heads up about this type of problems. I invited you to try to figure that out by yourself. And now we are going to just take a look at that type of a question. And in fact, you can have any trig function here, inverse of any trig function, and do the same problem. There could be quite a few of these things, in fact like 3 dozens of them, so we're just going to take a look at a few, and you can infer the rest from our discussion. So the best thing to do here is to draw a picture. So to get started, let's suppose the input that you're given is some positive number, and we draw a triangle. You can either use a unit circle or just triangle approach. When we say sine inverse of u, what kind of a picture should come in mind? We are looking at a situation where a number is given, and we are looking for the angle whose sine is equal to this number. So what's the easiest way to visualize this? Take the number and imagine that you have a triangle where the hypotenuse is 1, the same as the unit circle, and this angle is the angle that we are after, sine inverse of u. So sine of theta will be the opposite divided by hypotenuse. So in this picture, the triangle is going to match the expression that we have if the angle opposite of theta is u. So if I ask what is sine of theta will be opposite to hypotenuse, which is u divided by 1, which is u. And if I say what is theta, well, theta is sine inverse of u. Okay, so first we match a triangle to the equation we have in our mind. The second step, there would be a missing side, or hypotenuse. In that case, we just go ahead and fill in for that. So by applying Pythagorean theorem, if this is 1, this is u, this other side is going to be radical 1 minus u squared. 1 minus u squared. Now, what is the question? Question is, what is the tangent of sine inverse of u? Sine inverse of u is that angle theta. This angle theta we are referring to is sine inverse of u. Well, what's its tangent? Well, its tangent is ratio of the opposite divided by hypotenuse. So that's what I'm going to write here. Opposite is u, hypotenuse is 1 minus u squared. That's all there is to it. Now, if instead of u we had some other expression, more complicated expression, we just use what we have developed from in this case. So for example, here you see that instead of u we have 6u, otherwise all the same. So what I do is that I do a substitution. Wherever there is a u, I just put 6u. So this will, without any additional work, this is going to be 6u divided by 1 minus, that is 6u. So we are going to do a substitution. 6u is going to replace the u that we had here. Wholesale, all of the u's replaced by 6u. And then we have this. Now you can simplify a bit and write it like 1 minus 36 u squared. Now somebody might say, well, sine inverse of u could have been an obtuse angle. Okay, sine inverse of u could have been a number. Let me correct yourself. U could be positive or negative. The picture that we drew here implies as if it is positive. Well, what if u was negative? That is, we were in this unit circle. We are looking at u, and u is some negative value. Well, the angle that we are looking at would be this negative angle, and the tangent of it will be negative as well. So if u is negative, this tangent will also be negative, and automatically this formula that we have will come out and give the correct answer. We don't need to do any special thing to it for the case of a negative quantity u. Okay, let's go ahead and do another example. How about secant of sine inverse of w? Again, the trick is to draw a picture that helps us with the components. So w is just some number. In case you want to calculate sine inverse of w, well, w better be between -1 and 1. Now, what picture corresponds to that? First, let's suppose our w is a positive number so that we have a concrete picture to draw. Just like that problem we did, if I say an angle theta is equal to sine inverse of w, it means w is sine of theta. So this w has to be sine of this angle theta here. Hypotenuse is 1, and the other side turns out to be 1 minus w squared. So what's the secant now? Secant is the ratio of adjacent to the ratio of the hypotenuse to the adjacent. So it's going to be 1 over radical 1 minus w squared. So again, if the hypotenuse taken to be 1, then the opposite will be our sine. So w becomes sine of theta. The other side is going to turn out to be radical 1 minus w squared. Now I want to calculate the secant. Secant is the ratio of the hypotenuse divided by the adjacent. What if w was negative? If w was negative, well, yes, your angle would be negative. W is here, your angle is negative, but this other side still turns out to be 1 minus w squared, and secant in either case turns out to be a positive quantity. What if they had asked us what is secant of sine inverse of, say, 2x plus 3? Well, we do a substitution. Substitution means all of this is going to replace this and that one, and otherwise is all the same. That is, I'm going to have 1 minus, instead of whatever w I had, this new expression will come in, and I'll just do a substitution. So where would this kind of thing is going to come up by the time you arrive at calculus 2? You have the so-called trig substitutions for calculating something. Over there they call it an integral, and these are tricks of the trade in that setting. So the application is going to come sometime from now. Sine of cosine inverse of v. So we consider the angle theta. Cosine inverse of v is some angle. Let's call it theta. And just let's assume that let's assume v is positive, and therefore theta is in the first quadrant. What picture matches this? Well, this means that cosine of v is, cosine of theta is v. So suppose we have a situation in a unit circle, then that means that the hypotenuse is 1 and the adjacent is what the cosine is. So cosine of theta is going to be v. Well, what's going to be the opposite? From Pythagorean theorem, 1 squared minus v squared in square root gives you the opposite. What's the question? The question is, what is the sign? Well, sine of theta is going to be opposite of theta divided by hypotenuse, which turns out to be what you have. Now, what if v was negative? If v were negative, then you are dealing with, well, in the unit circle, when cosine is negative, it means your v is on the left side. So this is the v. And okay, if v is negative, your angle is going to be an obtuse angle here, but it doesn't make any difference to what this side is going to be. So if this is negative, when you square it, it will be positive, and everything is going to go same as before. So we are going to have 1 minus v squared. For the sake of practice, let's write something like the last problem. Suppose I had cosine inverse of 5t plus 2. Sine of cosine inverse of 5t plus 2. What would I do? It's simple. I just substitute this for that, whatever it is. So just make sure the parentheses is still there, 5t plus 2. And then that's our answer. We have one more problem. Tangent of cosine inverse of 2u. So we learned that it's best to first approach the problem of what is tangent in, what is tangent of cosine inverse of. Let's just concentrate on one single simple variable, cosine inverse of w. Then we are going to go on substitute. For w, we are going to substitute whatever we want to substitute. First, we draw a picture for this. We say, okay, that's an angle. That angle, let's call it cosine inverse of w, which means what? Which means cosine of theta is w. Well, what picture matches this? Let's just stay to unit circle. Let's hypotenuse is 1. Cosine, let's consider this angle theta. Cosine is the adjacent. So what is left is the other side, which is 1 minus, by Pythagorean theorem, hypotenuse squared minus side squared will be that. Next, what is it that we are asked for? We are asked for tangent. Tangent of theta is a ratio of opposite divided by the adjacent. So I'm going to have opposite divided by the adjacent. Now, in case we drew our picture for w being positive and theta as a result is in quadrant 1. What if w was negative? What if w was negative? W is negative. You're in this side. The angle that you are dealing with is a obtuse angle. The opposite 1 minus w squared, some positive quantity. But since w is negative, when you take the ratio, you get a negative answer, which matches to angles in quadrant 2. Their angles will be having a negative tangent. So again, in either case, we arrive at the same formula, and the formula takes care of all the plus and minuses correctly. Oh, excuse me, I should have written here. So tangent of w, excuse me, sorry. So what we have final answer is that tangent of cosine inverse of w would have been radical 1 minus w squared over w. And let me erase this. And then at the end we come and do a substitution. So okay, for w, if you have anything else, just do a substitution. You make sure you do the substitution across the board in all the places. So I'll have radical 1 minus 2u squared over 2u. And if you want to remove the parentheses, answer becomes 1 minus 4u squared over 2u. Either of these two will be fine. If you don't want to use the parentheses, that is how to write it. And let's see, cosecant of tangent inverse of 6w. So in this case we have, again, just like last problem, let's simplify cosecant of tangent inverse of let's call it, say, t. So this is some angle, let's call it theta, tangent inverse of t. So that means tangent of t, tangent of theta is t. What picture matches this? This is simplest picture we can come up with is that here's the angle, here's the adjacent, here's the opposite. This has to be t so that the ratio becomes tangent of this angle. Now our hypotenuse is going to be sum of squares of these two. So this is no longer the unit circle, it's just some triangle. Okay, now what is it that we want? We want cosecant of theta. Cosecant is the ratio of hypotenuse to the opposite. Here's the ratio. Okay, and in case we were in quadrant 4, t would have been negative, and cosecant would have been negative, and so on. Now all we are going to do is that instead of this t, we are going to use whatever variable I have here, which is 6w. So I just write 1 plus 6w squared over 6w, and if you want to simplify, that would be our final answer. Okay, so we had several of these problems. If you want to summarize, we have looked at 3 inverse trig functions. There are really 6 of them, but we just focus on 3 of them. And then we can make a table. So for example, if you wish, if you want to take sine of, let's say of sine inverse of x, so I'm writing a table so it looks a bit odd looking at the beginning. Sine of sine inverse of x, an angle whose sine is x. What is the sine of it? Well, just x. What is the sine of cosine inverse of x? We just, the exercises we did, we turned out to be 1 minus x squared. How about tangent inverse of x? So some of these things you can go and find for yourself. Is x over radical 1 plus x squared. If you want to take turns with cosine, so cosine, what it means here, cosine of, so the meaning here is a cosine of sine inverse of x, that's the meaning of the table here, is again just same as that, 1 minus x squared. Cosine of cosine inverse of x is just x. Cosine of tangent inverse of x is 1 over radical 1 plus x squared. If you want to apply tangent, tangent of sine inverse of x is going to be x over radical 1 minus x squared. and this one is going to be radical 1 minus x squared over x, and tangent of tangent inverse of x is just x. Now if you want cosecant, just take all of these and turn them upside down. So if you allow me, for cosecant of sine inverse of x, it's just going to be 1 over x. For this one is 1 over radical 1 minus x squared. For this one, it's just 1 plus x squared over x. Same way, secant of this is the reciprocal of that, 1 over 1 minus x squared, 1 over x, and this is going to be radical 1 plus x squared. And let's see if you have room to squeeze the other one. Well, cotangent of the above is going to be reciprocal of these things. So radical 1 minus x squared over x, and x over radical 1 minus x squared, and then 1 over x. In all cases, of course, we shouldn't divide by 0. At any rate, it's not a good idea to try to memorize any of these things. Best thing to do is to draw a picture. Unit circles and triangles are our friends here. We have to be able to reason our way to the answer, and hopefully you guys get the hang of it. So until next time, good luck and God bless.